Faster than light travel has been a staple of science fiction for as long as anyone can remember. Make some calculations, push a few buttons, and you're suddenly going at fantastical speeds. The reason for these wild inventions is due to the simple fact that nothing with mass can reach or exceed the speed of light. This has been widely known for over 100 years, ever since Albert Einstein proposed his theory of special relativity back in 1905. The phenomenon of a universal speed limit is often explained using relativistic mass, or the faster an object goes, the more massive it gets, until it reaches the speed of light and its mass becomes infinite. This requires infinite energy, which is of course impossible. However, the concept of relativistic mass is kind of controversial among physicists, and hasn't been definitely proven. Instead, we can use a few simple and well-proven equations and concepts to easily understand why the speed of light cannot be reached by an object with mass. Normally, when we add two velocities together, it's a simple addition problem. However, Einstein added a correction that shows that even if you can get a spaceship going 99% the speed of light to launch a capsule going 99% the speed of light relative to it, you will still not reach the speed of light relative to any observer. If we work out the equation, we can see that the final velocity of the capsule would still only be 99.99% the speed of light to an outside observer. Another way to show that the speed of light cannot be reached or broken by an object with mass uses the well-known equation E equals mc squared, or rather its complete form, where p is the particle's momentum, c is the speed of light, m is mass, and E is the total energy. Although this formula seems complex, we can apply the Pythagorean theorem and draw it as a right triangle with a hypotenuse of E and legs of pc and mc squared. By manipulating the triangle, we can see how a stationary object's energy comes completely from its mass, and how a massless particle's energy comes completely from its momentum. And by using the information that a particle whose energy is equal to p times c has no mass, we can assume that it is able to travel at light speed and set velocity equal to c. When we add it to this equation and rearrange it a little bit, we get a formula for velocity. We can now see that if momentum increases for any object, its p times c gets closer to equaling its energy, so this ratio gets closer and closer to 1, and its speed gets closer and closer to light speed. But if there is any mass at all, that fraction will never reach 1, and the velocity will never quite reach the speed of light. Or to put it simply, an object with mass will never attain the speed of light because the right triangle's hypotenuse is always longer than any one of its legs. Alright, but so what? Why does it matter if we can't travel at light speed? Well, even if we could travel just under it, it would take more than 4 years to reach the nearest star, and well over 50 to get to other habitable planets. So if humanity is to become an interstellar species, we have to find our way to work around the limitations of relativity and go faster than light. Thank you for watching.